Okay. We're ready. Looks like problem B. We're ready for problem B, 2B. All right, so I love it that you guys are so talkative with each other and you're all good friends, but we really need to focus now. So these are our directions. Those directions tell me two things. First of all, whatever answer I give is going to be in radians. If this said 0 to 360, the answer would be in degrees. The second thing is that is all the way around. So I potentially could have pictures drawn all the way around. That's what that means, go all the way around. So what have I got? I've got a cotangent that's a negative root 3. Now, I like to think of it as root 3 over 1 because when I memorized my functions, I memorized them all as fractions. Cotangent is adjacent over opposite. So I like to have a 1 there just to remind me it's a fraction. Does that make sense to you? Yeah. Okay. Now, somewhere in here, there's an angle. One of these or more have a cotangent that's a negative number. Start with that. You okay?
Yeah, I'm about to go home.
I think, girls, you put everything in his bag, right?
Yes.
Go give him to that kid that did CHS Live with you.
Mike?
He needs hooked up.
He does. Mike wasn't watching like
You were locked in. You were definitely locked
Alright,
in.
see you guys.
Bye. Feel better.
Thank you.
All right. He's such a nice. Okay. Here we go. Where could the cotangent be negative? That means one of these is negative and one of them's positive, right? So think about
2 and 4.
2 and 4. Let's look at that. In quadrant 2, the adjacent would be negative root 3 and the opposite would be 1. Does that work? And in 4, the adjacent would be positive root 3 and the opposite would be negative 1. I think you're right. Now, can you tell me how big this angle is in this triangle with the numbers situated like that? That's a 30 degree, but I'm supposed to be in radians. So 30 is a sixth of pi. Now the good news is when you have multiple triangles, they're all the same. So if you figured out that's pi over 6, this one's going to be pi over 6 also. You're not going to have two different angles in the same problem. Okay, now, pi over 6 is not the answer to the question because pi over 6 would be in quadrant 1. The answer to the question is this angle. So how are we going to figure out how big that red angle is? Pi minus pi over 6. That's exactly right. Remember, this is pi. So if you went halfway around, you'd be at pi, right? Well, we didn't go quite that far. We stopped here with pi over 6 to go. So that one is 5 pi over 6. Now, what about the other one? What about this one? We'll use the same logic, only it's not pi this time, it's 2 pi. So that one is 2 pi minus pi over 6, which is 11 pi over 6. Get prime denominator, this is 12 6, minus 1 6, right? 11 pi over 6. Okay, did that make sense to you? Well, we have another one just like it. Tangent equals 1. So again, I'm gonna think about that as 1/1. Tangent is opposite over adjacent. Even when we go to our calculator in the next problem, we are gonna have to draw a picture, because your calculator will only give you one of the answers. It won't give you both of them. So you're gonna need to use a picture to help you find both answers. We don't even have a calculator, we're totally on our own. We need to find somewhere where opposite over adjacent is 1/1. Where do you think that might happen? Certainly quadrant 1, because everything is positive, right? So 1/1. Where else will that happen? 3? And why does it happen in 3?
Those are both negative.
They're both negative. And so when you do -1 over -1, you just get 1. Now again, no calculator, so you gotta recognize this angle right here. What is it?
45.
45 in degrees,
Pi over 4.
pi over 4 in radians.
Are these all like gonna be like 30, 60, 90, or 45? Okay.
These. Now the next section, I'm using a calculator.
Okay.
They can be anything.
Okay.
But if I'm doing it by hand, they have to be pi over 3, pi over 6, pi over 4. That's all I got.
Yeah.
Okay, this one's also pi over 4. So now I'm ready to answer the question. And remember, the answers are the red angle and the green angle. So the red angle, because it's in quadrant 1, isn't it just pi over 4?
Yeah.
That's easy, quadrant 1. But the green angle has to go all the way around to here. So it went past pi, right? So it won't be pi minus. This one didn't get to pi, so it was pi minus. This one's gonna be pi plus. So pi plus pi over 4 is 5/4. And those are your answers. All right, now, get your calculator out and set it in radians. Again, for problem 3, this is still the directions. So the framework is going to be the same. The only thing is, our angles are not going to be 30, 60, 90 this time. Okay? That's all right. We can handle it. Tan x equals 1.75. Now, I don't need to label my sides of my triangle. I just need to know where are these triangles. If the tangent is a positive number, 1 and 3, isn't that what we just did?
Yep.
Now, if you want to label them 1.75 and 1 or something, that's up to you, but I don't know those numbers. So I'm going to let my calculator find this angle. So what button am I going to press since I need to know an angle? Second tangent, 1.75. So first of all, make sure your calculator's in radians. That's what this means. So go to mode, change it to radians, and then second tangent, 1.75. Did you get, it doesn't tell me how to round out, it's 200. Did you get 1.05?
Yeah.
Now this one is also 1.05. They're always equal. So your answers, just like before, are going to be this one, which is 1.05. And then our green one, which we're going to find how. How are we going to find the green one? add pi. So I just take my number that I have here, just hit plus second pi, and you should get 4.19. And those are the answers to the question. So we did it exactly the same way as we did it without our calculator. The triangle just wasn't special. So we needed our calculator to find the angle, because it wasn't 30 or 60. Okay? Cosecant, 7/3. Cosecant equals 7/3. All right, so what do you think about this? 1 and 3?
Yeah, you would go positive. I know.
What's cosecant?
Sun.
Okay, so does this mean that the sine is 3/7
Yeah.
and sine is opposite over hypotenuse? So in terms of the picture, wherever you draw your triangle, the opposite over the hypotenuse has to be positive over positive. Would you agree? Now, that isn't going to happen down here because the hypotenuse is always positive. So here, wouldn't the sine be negative? No. So that's not right. 2? Because in 2, isn't opposite also positive? Right? So another way to think about that is, remember, cosine is x and sine is y. So if sine is positive, y has to be positive. Would you agree? Okay. All right. What's my angle? I have no idea. So I'm going to second sine 3/7. I got 0.44. Did you?
4/4.
Yep.
Yeah.
So now I need to put down what the actual answers to the problem are, which I have been writing in green and red. So how big's my red angle? 0.44. We love quadrant 1.
We do.
And then my green angle is here, pi minus 0.44. Braden, are you second sine 3/7? Okay, that's the problem. I got 2.70. So there are the two answers to the problem. You good? All right, there's one more, and this one has a little bit of trickiness in it, so we need to talk about it. Secant is -3/2. Now, I don't know about you. I mean, I'm ancient, I do this for a living. I don't deal well with secants. So is it okay if I rewrite this like this?
Yeah.
That's gonna do two things. First of all, it makes sense to me that way. And secondly, now I can put it in my calculator. I can't put a secant in my calculator.
Yeah.
All right, so here I go. I gotta figure out where it is that the cosine would be negative. Now keep in mind, cosine is x.
2 and 3.
If x is going to be negative, you have to be in quadrant 2 or 3. Okay, now, here comes the tricky part. It's really only an issue with cosine, but it is an issue with cosine. So what I want you to type in is second cosine 2/3. Now, I I know that the problem is negative, but I have taken care of the negative by drawing it in these quadrants. Would you agree with me? These are the quadrants where cosine is negative. So any angle I put here is going to have a negative cosine. So if you second cosine 2 divided by 3, it says 0.84, which is this angle right here. If you second cosine the negative, it will not give you this angle. It gives you something else. And this is really the angle that you need. Because how will we find our red angle? This is going to be a red angle. How will we find it? Pi minus that. You need the reference angle. So pi minus 0.84.
Yeah.
And then how will we get our green one? Pi plus 0.84. And those are going to be the two answers to the problem. 0.84 is not an answer because when you type it in on your calculator, it's going to give you the reference angle, the little angle at the origin, and you got to get in the right quadrant. So in this case, it's pi minus. So second pi minus, and I got my red one is 2.30, and pi plus, I got 3.98. Did you get that?
Yep.
Okay.
Are we in quadrant 2 because whenever x is negative?
Whenever x is negative, cosine is going to be negative because cosine is x, sine is y. So they take their SIGNs, the positives and negatives, come from the quadrant that you're in. Yep. Okay, 4.5 is done. That homework will be due on Tuesday. And we're also going to finish 4.6 today because it is very, very easy. All right, so we're going to start. It is easy, and we don't go too in depth on it. Okay, so here we go. Sketch on your calculator, negative 2 pi to 2 pi. Okay, now this is my window. So I am already in radians. So I'm going to go to window, and I'm going to type negative, make sure you're using the negative button, 2 pi for x min, and positive 2 pi for x max. Now, the calculator will automatically change that into a decimal. That's fine. Negative 6.28 to positive 6.28. For your y's, let's just go with negative 2 and positive 2. And you'll see why when we do it, but let's just go with that. Now, go to y equals and type in your equation. Parentheses, sine x, close parentheses, squared. So when you type it in, it's going to look like this. Because these automatically come in. So you got to have this set and square it. All right, and hit graph.
Oh, this isn't.
Well, first of all, is there anything about that that you would expect? It's wavy, right? And we know sines are wavy. It's also squared, which means it's going to be all positive. That's why they're all on top. Notice that the height of it is 1. Why is that? That's how sine is. I love it. That's how sine is. Of course, that's how sine is. When you square numbers less than 1, you don't get bigger than 1, right? Everything is 1 or below. Beautiful, beautiful. All right, let's do the next one. Let's not change anything at this moment, but we might, but let's not change it. Let's just type in this new equation. X squared, just regular X squared.
As in, this is a part of like a new one?
This is a new graph, yeah, so clear out the old one. We're doing the next one to get a graph on it. Mm-hmm.
Did you have to put the parentheses before the 2?
Uh-uh.
After the 2?
The only parentheses there would be around the X.
Okay. Oh wait, yeah.
What shape did you get?
Parabola.
Looks like a parabola, doesn't it? Let's talk about that.
Okay.
Does that shape make sense? Now, first of all, kids, I am not gonna ask you to graph these things without a calculator, okay? So just calm down. But, do you expect that? Is there anything that would lead you to think it might have that shape?
X squared.
Well, x squared is a parabola. Now think about it. When we say we're gonna add 2 sine x, Kamara just said, sines are between 1 and -1. So I am just adding numbers between -2 and 2. So I'm not adding very much to these parabola values, so they are just keeping going, right? So it's a little bit off from a regular parabola, but it's still a parabola shape. We expected that. Perfect. Now, let's look at number 2. So again, if I ever want you to graph one of these things, I will. Okay? Now, number 2, is it a sinusoid? Why or why not? What is its period? What in the world are we talking about? Well, first of all, just for fun, let's go ahead and graph it. We're not going to have to graph them from now on, but just for fun, would you graph that 2A? 2A, clear out the old, put in the new.
Sinusoid.
We're getting there. Thanks for catching up. And just for fun, go ahead and change your window and make your mins and maxes 5. So negative y min -5, y max +5. And now you can see the whole picture. It's not going off the screen. So, without me even telling you what a sinusoid is, if you had to guess, do you think 2A is a sinusoid?
Yeah.
Yeah, why?
Looks like a sine.
Looks like a sine. Now, it isn't exactly a sine the way that we've written it, but it could be written as a sine. It is a sinusoid. Now, how can I tell that
Could it be a
without typing it on my calculator? Because this will be a no calculator problem. 1 is a calculator problem, 2 is a no calculator problem. So how are you supposed to know that? Well, here's what you do. What is the period of the sine? 2 pi. Because it just is, right? That's the period of the sine. What's the period of the cosine? 2 pi? When the periods of the individual functions, so this is a 2-part problem, it's a sine and a cosine. When the periods of the individual pieces match, it's a sinusoid.
What if they're not? When they're not?
Well, what if I stuck a number in there?
Okay.
What does that number do? Changes the period, right?
Yeah, okay.
So as long as the period of your first function is the same as the period of your second function, you're sinusoidal.
Are there like quadrusoids and like other?
No,
things like that?
because cosines are just sines.
Okay.
Now, next question, why or why not? Well, why? Because the periods are both the same. What is the period? Well, what is the period? 2 pi. If they match, that is the period. Now, if they don't match, we got another situation. And we're gonna do one right now. So here we go. What's the period of the first part? What's the period of a sine function? 2 pi. What's the period of a tangent function? Pi. Thank you, Robbie Rat. Pi. Is it sinusoidal? No, they don't match. Now, you can graph this as a periodic function though. Here's what the period of this is. So this is a 3-part question. Sinusoidal, no. Why? Periods don't match. What is the period? If I were graphing a sine and I started at 0, it would start over at 2 pi. That's what it means to be periodic, right? At 2 pi it starts over. And at 4 pi, and at 6 pi, and so on. So these are the places where my sine curve would start over. Now what about for the tangent part? Well, if I start at 0, it's going to repeat again at pi, and then again at 2 pi, and 3 pi, and so on. The period of the whole problem is the first time they both have the same number. So see how they both have a 2 pi? That's the period of the function. Now, they may have other matches down the way, and that's okay, but it doesn't matter. The first one, so the period of the whole problem is 2 pi, because that's the first time their start over points match up. Whew. All right, let's go to lunch.
Lunch.
Lunch. I want you back in your seats at 50. 50. Everybody back in here at 50.